Thank you to watching Shoaib Views channel. Today our topic on pumps and types of pumps. Before start this video, please subscribe my channel. If you like this video, please like and share. Pumps and their types. Objective pump and their types. Positive displacement pump PDP. PDP protections. Dynamic pump. Centrifugal pump and its operation. Centrifugal pump parts. Suction, discharge, total head and pressure and head relation. Ench with Encha and Encher. Centrifugal pump efficiency. Pros of centrifugal pump. Problem and remedy. Centrifugal pump protections. It is a device which used to displace a liquid. Pumps are classified by two types. 1. Positive displacement. 2. Dynamic. Further, there are two types of positive displacement. 1. Piston type. 2. Rotary and dynamic type pump, also called centrifugal pump. Positive displacement pumps. PDP has an expanding cavity on suction side and a decreasing cavity on discharge side. Volume is constant in each cycle of operation. Reciprocate in the screw and gear. Reciprocating pump. Suction and discharge valves are mounted in the head of cylinder. In suction, stroke plunger retracts and the suction valves open, causing fluid enters into the cylinder, while in forward stroke the plunger pushes the liquid out to discharge valve. Rotary pump. It operates as a rotating screw gear, traps the liquid in the suction side of pump casing and forces it to discharge side of the casing. Pros: self-priming capability and producing a high suction lift. Con: it operates at low speed due to close clearances. Otherwise, high-velocity liquid would increase clearances, resulting slippage. Slippage is leakage of fluid from the discharge of the pump back to its suction. Screw pump. A single screw rotates in a cylindrical cavity, thereby moving the material along the screw spindle. AUS. Two screws pump. One screw has a right-handed thread and other screw has a left-handed thread. One shaft is the driving shaft which drives the other shaft through a set of herringbone timing gears. These gears serve to maintain clearances between the screws. 3 screw pump. Pressurizing pump. Center screw is used to drive the two outer idler rotors. As the screws rotate in opposite directions, the pumped liquid moves along the screw spindles that used to pump high-pressure viscous fluids like lubricating, hydraulic, or fuel oil. Positive displacement pump protection. Relief valve fitted on their discharge side to protect the pump and piping from overpressurization. For example, if the pump discharge valve is shut during pump operation or if clogged strainer block system flow, suction line must full with fluid. Otherwise, it will take air. Gear pump clearances must be minimum to protect slippage problem. Centrifugal pump. Rotating impeller used to increase P and Q of a fluid. In radial flow, fluid enters along the axial plane and exits at right angles to the shaft radially. Gives higher pressures and lower flow rates. It consumes more power as flow increases due to resistance. In axial flow, impeller pushes the liquid in a direction parallel to the pump shaft. Fluid is lifted by the action of impeller. It gives low pressure but high flow rate. Consume less power as flow increases. CW fan. In mixed flow, pumps borrow characteristics from both radial and axial flow pumps. Fluid accelerated and lifted and exits the impeller somewhere between 0-90 degrees from the axial direction. Operate at higher pressures and delivering higher discharges. QUP. Pump operational description. Fluid suction line. Pump casing channel. Impeller vanes gives rotary motion. Volute reduce velocity and increase pressure. Discharge nozzle. Pump has small drain and vent fittings to remove gases. Centrifugal pump parts. Wearing rings are replaceable rings which attach to impeller and pump casing to allow a small running clearance between themselves without causing wear of impeller or pump casing material. Pump efficiency increases by minimizing liquid leak through this clearance. Shaft transmits torque during starting and operation, also supporting impeller and other rotating parts. Pump shafts are usually protected from erosion, corrosion, and wear by renewable shaft sleeve. Impeller main rotating part that provides the centrifugal acceleration to the fluid. Couplings used to connect motor with pump and transmit torque to the impeller. Casing volute reduces velocity of liquid and increases its pressure. Bearing anti-friction plain bearing housing encloses bearings mounted on the shaft. Bearings keep the shaft or rotor in correct alignment with the stationary parts under the action of radial and thrust loads. Stuffing box seal the shaft gland packing, pusher, lantern ring, and sleeve. Pump suction may be under a vacuum so that outward leakage is impossible, or fluid may be too hot to provide adequate cooling of the packing. In these conditions, lantern ring is used. That is hollow ring which receives relatively cool, clean liquid from either discharge of the pump or from an external source, and distributes the liquid uniformly around the shaft to provide lubrication and cooling, or seal the joint between the shaft and packing against leakage of air into the pump in the event the pump suction pressure is less than that of the atmosphere. Gland is a very important part of the stuffing box. It can be easily adjusted in axial direction. It provides sealing of shaft in the stuffing box. Sometimes packing material is not adequate for sealing a pump shaft. Mechanical seal used where we need 100% sealing, like expensive and dangerous liquid. It consists of two basic parts: rotating element soft face attached to shaft and stationary element hard face attached to pump casing. Both has a highly polished sealing surface which prevents leakage along the shaft. It provides sealing from four sides: sealing between shaft and sleeve by O-ring, sealing of sleeve and soft face by O-ring, hard face by O-ring, and face-to-face sealing done by compression to soft face. Precaution: soft and hard face both are polished, and unnecessarily touching is not allowed. Also perform their fittings very carefully. To be continued. Thank you to watching ShowAbViews channel. This was the part 1 of pumps and theotypes, in which I discuss the pumps and theotypes and parts. In part 2, I will discuss about pump efficiency and troubleshooting. If you like my videos, please like, share, and follow me and subscribe my channel.